we are going to be talking now about operations with files and how we copy files and move files, link files in the experiment. How is it configured and in the defaults, and how can you actually change that? And a little bit of a disclaimer here, because the folder, well, it's not a disclaimer, it's an apology. The folder structure of ESM Tools is a bit crazy, and we are going to be fixing that soon, as everything we say we are going to be fixing soon. But that's how it is right now. And it's been quite stable and working for now, so you need to learn this, and then eventually we'll change to something more simple. So we have two levels of folder structure for, let's say. So one is the general experiment folder. You're very familiar to that. That's basically where you say base year, and I mean the path to that is base year and plus the experiment ID. And you have a series of folders here that contain the restarts for all your simulation, the configs for all your simulation, and the output data for all your simulation. And inside that, you also have a bunch of run folders. These run folders are run folders specific to a single run, and they are timestamped with the date of that run. And we have seen that already. The structure inside on this second level in the run folder is identically the same to this one, but it has a work directory. And that's actually where everything is copied to for making that run happen. And that's actually where the run happened and where the files are output ideally. Okay? And then what ESM Tools does, what ESM Tools does is at the beginning of a run, it copies everything to the work directory from the name list, I mean, again, these are templates, so they are parsed and edited, but still they come from the name list. The binaries come from the model dir if it's the first run. If it's not the first run, they come the binary here, folder. And the same goes for the input and the forcing. So for the first run, they are copied or linked on the pool, and then they are passed into here, and then they come from the experiment, from the general experiment folder. So that if something changed, something changed from the beginning of your simulation, you are containing everything inside here to reproduce this simulation. That's if you are not linking. Obviously, if you are linking and something changed in the pool, it's changed also for your experiment. But the pool should be safe enough anyway. And if this is, for example, a second run, not the first run, it's also going to be taking the restarts from the general experiment folder and putting it into the work folder. It's not exactly like that. Okay, this is the beautiful scenario, and this is how it will work in the future, and you won't have all these many folders. But what it actually does is, for example, let's say we have an input file and we are copying this input file. So we take it from the input, we paste it on the input, and then from the input, in the run folder, it goes into work. That was done for safety reasons, for keeping the run folder super pristine and that you can reproduce everything. But in the end, I don't think this makes sense anymore.
Yeah, perhaps a bit of explanation why this weird structure, right? Why this crazy structure? I think it comes from a time when model resolutions were lower, file sizes were relatively small, and the main safety concern was, or the main concern was to make it safe, right? So if it meant that you have like 3 or 4 or 5 copies of all your files, that was completely acceptable, so long as your run was safe and you could always reproduce it, and it was good for the time. But it's a little bit out of time, right? When the main problem that we are facing is usually that our disk is full rather than we run out of node hours. Having all the files like 3, 4, 5 times around is no longer the main, is no longer really helpful, right? And that's why also it changes. And we have also a change in the lead of the ESM Tools development team, of course, so that, you know, a lot of the decisions that were made for this very safety heavy implementation of ESM Tools were done by Dirk Barbie, previous main developer. And so now it's going to be a little bit more of a, I would say, faster machine, but if you link more, there is more things that can go wrong, right? It was safer perhaps before.
Okay, so we look at the case for when we were starting a run, and what happens at the end of the run. We already talked about this. At the end of the run, we copied the restart files into the restart folder, and also the data in the out data folder. And yeah, we also copied like the configuration files, such as we actually move some of the configuration files. This finished config, we move it into the general config. What does that mean? That means that if you are searching for the finished config of a simulation, a run that has already finished, and you are, for example, in run 3 and you want to look at run 1 finished config, you are going to be looking for the file here. So the rule of thumb is basically that if you cannot find it in the general folder, or if you cannot find it in the run folder, look for it on the general folder, and it should have a timestamp at the end of the file. So if you cannot find a file that should be here, just look for it there. Super intuitive.
What comes into the analysis?
Analysis. So analysis is just a folder that is created there that does nothing unless you do a post-processing analysis.
Okay.
And then you can put stuff there. So it's a folder that is there created for you to inspire you to, hey, put the files here. Okay, so how do we control all these movements? We use a feature dictionary that is the file dictionaries. So with that, we can decide whether we copy, move, or link files into our simulation and select among different files on the pool and rename files also. So the syntax is of the keys of this dictionary is composed by 2 elements, separated by an underscore. So the first element is the file dictionary type, and that would be, for example, the binaries, or the configs, or the forcings, or the out data. Restart has 2, because you have a restart when you want to bring things into the work directory, and also a restart for when you want to bring things from the work directory to the general directory. Okay, so in and out. And then you can concatenate to that in the key with an underscore to the different options. We have a files option, a sources option, and an in-work option. So let's start looking at the sources option. So for example, we say that we have a type of file that is called input, and that's basically input files. And we add the option sources, where we, in the first part of the dictionary here, it's a label for that file. So kind of a tag that we can refer it in other places. And then it comes the path for the file. And you can see that the path of the file, it uses variables from ESM Tools, so that this is pretty generalized and work for different computers and work for different options inside a choose or something like that. So that's the sources, and this is basically telling you where the input is coming from. Okay? So it would be the pool, for example. And then we have the target, which normally is the in-work folder. Sorry, is the work folder. So and for that we specify in-work. So the syntax of that would be input underscore in work, and then we are saying, okay, for the same file that we are labeling with the sources within the sources with this key, we are going to have a new name for the target folder, which is in work. Okay, so we are seeing here already that we can do we can not only copy or link, but we can also rename on the fly. So if we were looking here back, the name of the file was different than in the source, than in the target. And that might be necessary because, for example, for OpenIFS, it needs to have a standard name entering into it. And you cannot just give, so this needs to be like, this is like this in the pool directories, but you need to rename it so that the model understands and takes this file. Okay, so it's basically the two parts of a copy command, CP, source, target. Okay. And then the final operator is the files operator. So here what we want to do, so we have again the sources and we have the target. And now these are on the configuration YAML files defined, and you can define as many of them as you want, but you might not want to use all this data. You might not want to use all these files for different options, right? You might want to use, for a specific option, you might want to use only the first one. How do you do that? You can control that with input files, and basically you define the key being exactly the same as the label. And what you are saying here is, I want you to include in my simulation, in my experiment folder, I want you to copy this file into the work directory, this one, label as here, yeah, with the source and the target.
Perhaps in a practical example, let's say you have forcing files for different SSP scenarios, right? You want to define them all ahead of time, right? For historic, it's this. For RCP or for SSP 8.1, 8.5, it's this. And you have like 10 different files there. So they're all already defined, but then you only want to use one of them at any one time, right? So that would be.
So files operator allows you to select which one you choose. And that's why they have target and sources. This is a very confusing syntax. This is the next thing we are gonna be cleaning up, most likely. Huh?
Quite soon.
Quite soon, in a week. We actually have the sprint set up for that. So yeah, and we are gonna make it in a much more intuitive way in which one single file, it's sort of an object and it contains a target, a source, and how you copy this file. So everything is going to be contained in one single dictionary and describes exactly the behavior of that particular file. And then you are probably still going to need something like input files, so like somewhere where you select the files. Anyway, it's going to be much better because this is a chaos and it gets even more complicated. So there are exceptions where in some point, for example, at the end of the run, our work directory is our source and our restart directory in the general folder is our target. And the way of doing that is basically in work. We know that out data, I'm even confused with that. We know that out data in work is this time the source, and ESM Tools knows that. And then the target is going to be the sources. Yeah. And sorry again. Yeah. But anyway, the good news is that this is not something that users are going to be using a lot. You have already used this feature in a much more intuitive way on the previous exercise when you were selecting the config sources. Do you remember that you have changed config sources and changed the name list.io? So again, what you were doing, if we look at this example here, you had instead of input, you have config sources. So what you were doing is you were telling ESM Tools, okay, I want to ignore the source of my name list that is defined by default in the FESON YAML, and I want you to use this particular source, which is my particular name list. And then the target, you don't need to touch it because the target is the same. It's going to be called the same. But you could have, for example, a name list that was named differently, and you actually, I think, you actually changed the name you actually change the name of the source, right? Like the name list was called mynamelist.io, and in the end,
My own name.
my own name is .io. But when you look at the experiment, the name list was called namelist.io.
Yeah.
So you've already used that, and that's so name lists are config files, and that's why you need to use config instead of input.